Okay, so today we're going to be talking about interval notation. So this is lesson 8 of unit 1, and our essential question is, what are the different ways to represent number sets and why is it important? And our target will be to understand there are several methods used to represent sets of numbers in higher mathematics. So a few types of notations we use are inequality notation, which represents numbers with inequality symbols like less than, greater than, less than or equal to, or greater than or equal to. Graphical notations represents numbers on the real number line. This symbol right here is an indicator of real numbers, and we'll talk about symbols in more depth in a little bit later on in the lesson. Set notation represents numbers with set builder symbols. And then there's interval notation that uses intervals. Now, these different symbols here. Parentheses are for when you have less than or greater than. The brackets are when you have less than or equal to, greater than or equal to. Okay? And then we have these symbols called union and intersection. So union indicates or, and it looks like a U, so U and union. And the upside down U, which kind of looks like an A without a line through it, is called the intersection of two sets, and that's used to denote and.
Hello.
What happened?
I was a little late. I had to go to my car.
All right, well, after week 1, remember, or week 2, you have to make sure you're here on time. You have to get a hero pass. Okay, moving on. So now we're going to talk about the different types of notations, okay? So what does this mean? How would you say this in math? Like if I said, what is this saying right here? X is, yeah, go ahead.
Less than 3.
Thank you. X is less than 3, right? So now we're going to graph it on the number line. So number line goes from negatives to positives, negative infinity to positive infinity, and you can just put your 3 down somewhere on that. And is this going to be an open or closed circle? Open. Thank you. And why is it open? You got it. And X is less than 3, so which way is my arrow going to go? Yeah, it's going to go towards the negatives, right? It's going to go to the left because we're talking about values less than 3. So now we're going to talk about interval notation. Okay, interval notation. So with interval notation, we use intervals. So anytime you're dealing with negative or positive infinity, you're going to use a parenthesis. Okay? So remember, we're going from negative infinity, always reading from left to right in math, so that's why we start with negative infinity. And we're going to 3. Now, is 3 a closed or open circle? Open. So you use a curved bracket or parenthesis there. So when it's an open circle, you use the curved. And we'll do an example of a closed as well. Now we're going to talk about set builder notation. So in math, when we're talking about mathematical sets, we use this squiggly bracket. Okay? And this is going to denote a set. So when you're talking about a set, we usually say X such that. So it's like a straight line. And that's what that means. That's how you say that in math. X such that. And then we would say, what are the bounds of X? So in this case, the bounds of X are X is less than 3. And then we close it with a set ending. So it's very similar to inequality notation, but you have this extra set builder notation around it. And with the set builder notation, when we say X such that, we're implying the set of real numbers, which are non-imaginary numbers. So that's what that indicates. So let's move on to B. So I'm going to plot 3 on the number line somewhere. And is this going to be an open or closed circle? Thank you. And then which way is my arrow going to go here? Good. It's going to go towards the positive because we're talking about values that are greater than or equal to 3. So is 3 included in this case? Yes, it's included because we have the equal to. So now we're going to do our interval notation. So remember, you always work from left to right. So the first thing I have on my left is 3. Now because 3 is a closed circle and it's included, we're going to use a bracket here. See the square bracket. comma, then we're going to positive infinity. Now, anytime you close a set with infinity, negative or positive, you always use a curved bracket or a parenthesis. So whenever you have infinity there, the infinity always has a curved. Make sense? All right, now we're going to do set notation. So x such that x is greater than or equal to 3. So now we're going to move on to C. And what do you notice is different about C? Good. Anybody know what we call this kind of inequality? Starts with a C. Compound inequality. This is a compound inequality because there's two inequalities and x is bound by -2 and 5. So we're going to plot -2 and 5 on the number line. And make sure you go in order from least to greatest. And now we're going to determine what kind of circles we have above each. So above the negative, is it going to be open or closed?
Open.
And above the 5?
Closed.
Good. Now we're going to determine which way my arrows are going to go. Now anytime you have a compound inequality like this, the x is going to be between, because it says -2 is less than x, which is less than negative or positive 5. So right here we're going to connect these two dots. And what this means is our value for x falls somewhere between -2 and 5, and 5 could be that number. It's included. The -2 is not included. So now we're going to do our interval notation here. So for interval notation in this case, is the -2 included or not? No. So what kind of bracket do we use? Use a curved bracket when it's an open circle. Okay, if there's no equal sign here, you use a curved bracket or a parenthesis, however you want to say it. And then what about for the 5? Yeah, it's a square bracket. Is everybody starting to see the difference between when you use one and the other? So square bracket, look for the equal sign here. Look for the closed circle here. Parenthesis, look for no equal sign here and look for the open circle. And now we're going to do set notation. X such that -2 is less than x is less than 5. So next we're going to look at D. So x is greater than -2 and it's less than, x is less than 5. So once again we're going to plot -2 and 5 on our number line. And is it going to be an open or closed circle above the -2? Good. And what about on the 5? Good. So now we're going to determine the direction of our arrows. Okay? So which way is the arrow going for x is greater than -2? Yeah, towards the positives. And then what about if x is less than 5? So what do you notice happens with the two arrows? They intersect. Good. And what happens is here, what do you notice about C and D? What do you notice about these two? They're actually the exact same, right? See how the number line, the graphical notation ends up being the same? So these two are two different ways to represent the same thing. So I do want to note that compound inequalities can also be written as and intersection inequalities. Okay? So there's two different ways to write the same piece of information. So they're the same information represented two different ways. So for interval notation, there's two ways you can really go about doing this. You can use the interval notation here, like this, or you could write it as two separate interval notations and use the and section. Okay, so how you could write it is, you could say, well, from -∞ to -2, and, never mind, we're not going to do it this way, it's too complicated. I'll just show you the easy way. I don't want to confuse anybody, sorry. So we're just going to rewrite it the same way we do this one, because we're including the same values. And then for the set notation, x such that, you can write it as the compound inequality, or you can say x is greater than -2 and x is less than or equal to 5. So I do want you to note that C and D are the exact same problem, but written two different ways. So I do just want you to note there are multiple representations that are correct in this situation. So if you had written this here, these are both correct. So either one is acceptable unless specified otherwise. Any questions on that? Remember, this symbol means and. Alright, so we'll move on to or. Okay, so for or, we have -2 and we have 5 on our number line. So is it closed or open, the -2? Good. And what about for the 5? Good. And now we're going to determine which way we're going to go. So, what do you think for the -2? Yeah, we're going to the left because it's less than -2. And what about for the 5? Good. So this one's a little bit different. Okay, this is an or inequality. So, how you would write this is from -infinity to -2, and -2 is included, so that's why I'm using a square bracket. And then we have or. So what symbol do we use for or? Does anybody remember from the last page? Looks like a U. Or. And then we're going from 5, which is not included, so I'm not going to use a square bracket, up to positive infinity. And with infinity, we always use a curved bracket. Now the two ways that you could write the set builder notation here are x such that x is less than or equal to -2 union x is greater than greater than 5, or you could just write it as the word or. So those are both correct. So basically this right here symbol means or, and this symbol right here means and, which is on the last page of your notes. I just wanted to refresh on what I was talking about. So do we have any questions so far? Okay. So now we're going to move on. We're going to talk about what set notation is and how to read it. So as you go higher in math, you're going to start noticing we're using almost like a language. We're going to use different symbols that mean different things. So set notation, this right here, these symbols are indicators of a set in math. Okay? A set of numbers. And there's numerous set of numbers that you can have. You can have finite sets, you can have infinite sets. And right here, when we say x, and then we put a slash here, this is all x values. Now when you use set notation, it's important to note that whenever you use set notation, you're implying that we're talking about the real number set. So the real number set is basically your default set that we talk about with set notation. Now, if you want to indicate a different set, you have to make sure you note that information. So if you want to talk about one of these other sets, you need to let the person who's reading it know that you're changing the set. Okay, so think of it as like the default setting is real numbers, and anything else you're going to have to notate that because it's not implied. Okay, so There's other types of number sets. We have the natural numbers, which are like 1, 2, 3, 4, and so on. We have the irrational numbers, which would be like pi and the square root of 2. We have integers. So integers are numbers that are non-decimal, like 0, 1, 2, 3, 4, counting numbers. Complex numbers are numbers like that have I in them, the imaginary set. Imaginary number plus a regular number or subtracted from a regular number. We have the rational set. Rational numbers can include integers as well as terminating decimals. Imaginary is numbers like the square root of -4, which is 2i, as well as subsets. So you can also talk about positive integers, and you indicate that with a positive sign. If you want to talk about negative, you put a negative sign afterwards. So that's just the basics. And now we're going to use set notation. So we're going to try to use set notation, and then when possible, we're going to use interval notation as well. Interval notation I'm going to do in red. Now, there are times when interval notation is not explicitly stating directly what you're talking about when we're changing a set, so I'll explain that as we go through. So, all real numbers, if we're indicating that with an interval notation, that's going to be from -infinity to +infinity. In set notation, that's going to be x such that x is an element of the real number set. So this right here, this weird e, it means element of. So now we're going to talk about real numbers except for -5 and 5. Okay, we're leaving those two numbers out. Now, in this case, the interval notation is actually pretty complicated, and I would expect you to write it in set builder notation. It makes a lot more sense in that notation. So how you would have to write that is, well, we're including -infinity all the way to -5, but -5 is not included, right? The union of that, and then we would go from -5 to 5, but neither are included. And the union of that with, then we'd go from 5 to infinity. So, in this case, the interval notation is quite complex, and I probably wouldn't expect you to do one this difficult at this stage, okay? Now, for the set notation, it's a little bit easier. That's going to be x such that x is not positive or -5. So the benefit of the set builder notation is it assumes all real numbers. This portion of the set builder notation indicates we're talking about all real numbers, and you can just say which ones you want to exclude. So that's why this set builder notation is useful. When we're talking about interval notation, you have to explicitly state everything you're talking about. Now let's talk about all negative real numbers. So where do the negative numbers start in math? After what number do they start? 0. Good. And is 0 a negative or positive? It's a trick question. It's actually neither. So 0 is neither negative nor positive. It's considered neutral. So we use it as a reference point for a lot of different mathematical things. So all negative real numbers are going to be numbers that are less than 0. So when we're talking about interval notation, that's going to be -infinity all the way up to 0. Now, is 0 a negative number? No, so we're not going to include it. That's why we use a curved bracket. Now for set builder notation, that's going to be x such that x is less than 0. Now, if we're talking about all non-negative real numbers, what do you think of when I say non-negative numbers? Good, numbers that are more than 0. What other way would you say it? Positive numbers, right? So this would be all positive real numbers. So if we're talking about positive numbers, we know those numbers are going to be greater than 0, right? Good. So we're going to talk about numbers from 0 to positive infinity. And 0 is not included because 0 is not a positive number. You start getting into positive numbers directly after 0. And in set builder notation, that's going to look like x such that x is greater than 0. So a lot of times in higher math, if they want to indicate to you that they're talking about numbers that are positive, they'll tell you all numbers greater than 0. And you have to make that implication and understanding on your own. So this stuff does come up a lot if you're going to go into calc and beyond. Now we're going to talk about e, which is all positive integers. Now, what did you notice changes here? We were talking about real numbers, real numbers, real numbers, and real numbers. Now we're talking about what? Integers. What's the difference between an integer and a real number? Yeah, so we have a set of real numbers. If you want to write like this, you have a big set of all the real numbers in the world. Okay? And within that set, we have an even smaller set of positive integers. So integers that are positive. And integers are denoted by z. So all real numbers, well, real numbers include irrational numbers like pi, but integers are numbers that are like 1, 2, 3, 4, 5, 6, -2. Those are integers. Integers are numbers that are non-decimal. So it's a smaller subset of the real number set. So we have to indicate that when we're using set builder notation. So this one I'm only going to do set builder notation because if you use interval notation here, it's going to not explain the fact that we're talking only about integers. So when you want to indicate a change in the set, we have to use set builder notation. So remember, this implies x such that, and it always implies real numbers. So we have to change that. We have to say x in the positive integer set such that x is greater than 0. So we have to imply that we're now referring to positive integers. So does everybody understand the difference between D and E? In theory, what those sets would include that would be different from each other? So for example, D would include like pi, like 3.14, whatever repeating. But E would only include like 3, 4, 5, and 6. So do we have any questions about this? Okay, so you have the rest of this half of the period to work on your homework. You should have time to get it done, actually, if you work through it right now. Did anybody have an issue submitting their homework yesterday, 1-4? I had a few people say they couldn't submit it. If you did have an issue, I did open it up for another 24 hours tonight, so you can submit it. What? You did have an issue? Oh, okay.